This is just a note to keep in mind. Vectors do not have to be in standard position to be written algebraically. So to make sure you can read this, this is a representation of a vector as an ordered pair. Let P1 be x1 comma y1 be the initial point, and P2, point 2 in other words, is x2, y2 be the terminal point. And the ordered pair that represents vector P1, P2 is vector coordinates x2 minus x1 minus y2 minus y1. Its magnitude is given by the absolute value of the vector, which is the distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. And then vector operations, following operations for vector A, which is A1, A2, vector B, which is B1, B2, and any real number k. Addition of vector A plus vector B is the vector coordinates A1 plus B1, comma B1, or I'm sorry, A2 plus B2. And the subtraction of vector A minus vector B is the coordinates, vector coordinates A1 minus B1, comma A2 minus B2. And then scalar multiplication, remember k is just any real number, so k times vector A is k times the coordinates of vector A, A1, A2, which is k times A1, comma k times A2. So in a scalar, all we do is multiply the coordinates. Okay? I have a couple examples I want to do with you that should help you understand what we've written here. And then looking back at this for just a minute, the order in which I subtracted these is important. Okay, it's very important that I subtract in the right order. And I'll point that out as we do the example. Okay? So, let me pause while I copy this down. So the example, write the ordered pair that represents a vector from x, which is 6, 2, to y, which is negative 3, 4. Then find the magnitude of vector xy. Remember, the first thing I said is vectors do not have to be in standard position to be represented algebraically. Right? And so this vector is not in standard position. Its initial point is at 6, 2, and its terminal point is at negative 3, 4. Okay? And so the way of doing this is we subtract the terminal point. This is y1, y2, and x, I'm sorry, this is x2, y2, and x1, y1, and we want to subtract the terminal point minus the initial point. And always subtract the terminal minus the initial. Okay? Always subtract the terminal minus the initial. And so xy, vector xy, is equal to what? Negative 9, 2. Okay? All right, good. Now, we want to find the magnitude. So the magnitude is the square root. In other words, it's a distance formula of this same thing up here. So it's negative 3 minus 6 squared plus 4 minus 2 squared, which which is negative 9 squared plus 2 squared. Now I put that in parentheses because many people still make a mistake here. I checked your test last night. I saw the same kinds of mistakes. If you leave the parentheses off and you do this, many of you are telling me that's negative 81. Because the opposite of 9 squared is a negative 81. In your calculator, if you plug it in like that, it's going to say negative 81. Because it knows the difference. Okay? But what you're really wanting to do is to square whatever that number is, which is a negative 9. And when you square negative 9, you get a positive 81. Okay? So be careful that you don't fall into that trap. So this is 81 plus 49.
It's a 2.
Oh, thank you. I couldn't read my own writing. Two squared is 4, so that's square root of 85. And so if they say round to the 10th, then we get 9.2. I spoke while you spoke. Was that right, 9.2? Okay, so the magnitude is 9.2. Okay? That's if they say to round. All right, any questions on that example? Okay, let's move on then. If I have vector u with coordinates 1, negative 4, and vector v with coordinates 0, 8, and there's 4 parts to this question. One says, what is u plus v? One says, what is u minus v? One says, what is 1/2 v? And the last one says, what is 2u plus 3v, I think I wrote. Yep, 2u plus 3v. Okay? So using vectors u and v as we gave at the beginning, they want us to find these 4 operations. Okay? So what do I do with the first one? Find the vector coordinates, the question asks. 1 plus 0, comma, negative 4 plus 8. Is that what you said?
Yeah.
Okay, good. And so you get 1, help me out, 1, 4. Okay? Now how do I do B? Okay, set it up the same but use minus, someone said. So 1 minus 0 and negative 4 minus 8. What does that give me? 1 negative 12, that's correct. Just so that we don't lose anybody, let's go real slow and tedious and show the first step here, even though not much is accomplished. How could I write this, the first step on this part C?
1/2 times quantity 0, 8.
Thank you. And then let's write, what does that mean?
I was just going to say put it all over 2. 0 over 2, comma 4. So 0 over 0, comma 4.
So So it's 1/2 times 0, which is 0 divided by 2, and 8 times 1/2, which is 8 divided by 2, and you're telling me the answer is 0, 4. Okay? Now I know that when you're doing your homework, if you get this, you're just going to go straight to the answer, and I'm okay with that. But in our notes, I want to make sure that you don't wonder, well, where'd that 4 come from? Okay? So let's show that tedious step. So if for some strange reason later on, you think, well, how did we do that? You can look back at it and it'll be real obvious to you. Okay? And then part D. Again, let's go tediously slow, since it's our notes.
2 times the quantity 1 minus 4, or 1 negative
1
4.
negative 4 plus
3, 0, 8.
0, 8. And then this would be 2 times 1, 2 times negative 4. And 3 times 0, 3 times 8.
How come it's not like regular differences?
These symbols mean vectors, where these symbols just mean ordered pairs. Okay? So that just means they represent a vector, a segment or a ray drawn from the origin to that ordered pair. They don't represent the dot there, they represent the movement of that vector. Does that make sense? Okay, good question. Sorry I hadn't already made that clear to you. And so again, going slow, this is 2 negative 8 plus 0, 24. I know this is tediously slow. This is 2 plus 0 and negative 8 plus 24. And the final answer then is
216.
sorry, thanks. I could hear you. I just was thinking wrong and wasn't agreeing with you at first. But you're exactly right. I was looking at this thinking I was still up here and I was wanting to add my 2 and negative 8 together instead of actually doing what it said to do. Okay? I went so slow I walked myself into sleep there. All right. So again, I know that's tediously slow. You would never show all those steps. I wouldn't ask you to. Okay? I would probably show the step where I went directly from here to here, and then directly from there to here. Okay? I would probably show those 2 steps. That's what I would show if I wanted to show my work. Okay? Any questions on that? All right. The majority of your work is going to be that simple stuff right there. Okay? The majority of it's going to be just like that. Now, my notes are a little bit incomplete, but there's one more thing in the book that I want to make sure we talk about called unit vector. I'm going to pause this while I write. So a unit vector is 1 unit long. I represents the unit vector 1, 0. J represents the unit vector 0, 1. Okay? So I represents the unit vector 1, 0, and J represents the unit vector 0, 1. They're 1 unit long. Now we can take any vector and put it into unit vector coordinates. Okay? Unit vector coordinates. It doesn't quite sound like the word I wanted. Okay. I guess we'll live with that. And we'll show it as the sum of unit vectors. So if I just make up another example here. And if I just make up we'll call it xy, sorry, x, which is 2, negative 3, and y, which is, we'll say negative 1, 4. Okay? We want to write vector xy as a sum of unit vectors. Okay? We want to write vector xy as a sum of unit vectors. So the first thing we have to do is find what is the vector coordinates of vector xy. So step 1, find the vector coordinates of vector xy. What would that be? 1, 1?
Yeah.
That's why we go tediously slow in notes sometimes. Vector xy is equal to negative 1 minus 2, 4 minus negative 3. Remember, it's a terminal minus the initial, right? And the way this is written, this is the initial, this is the terminal because of the direction of the arrow above it. Okay? And so this is x to y. So we subtract y minus x. And so the coordinates of xy, vector xy, are negative 3, 7.
But doesn't it say the sum, so when you add it?
Okay, so the first step is now complete. Find the vector coordinates of vector xy. Now we want to write it as a sum of unit vectors. And what does the I represent?
0, 1, 1, 0.
1, 0, which is the x coordinates. What does the y or the j represent?
So the y coordinates.
0, 1, which is the y coordinates.
So it would be negative 3i and then 7j.
That's correct. Negative 3i plus 7j. Negative 3i plus 7j. That's how we write that. Okay? Any questions on that?